Welcome to another GMAT explanation. We're still using the online whiteboard tool just to provide some best practices for using this tool. For this one, we've got powers of 10. So normally powers of 10, I would aim for the pen tool because the keyboard doesn't work so well manipulating exponents. That said, because it actually doesn't look like we're going to be working with the exponents too much, and we're just going to kind of be making a list of numbers, I would go for, I think the keyboard works well in this case. So I would go ahead and make a nice big canvas, hit enter a bunch of times so you have space. And we're talking about the primes less than 20. So let's just carefully list those out. Let's remember that 1 is not prime, 2 is the smallest prime. It's also the only even prime. And just take your time making this list. There's no glory in being able to shoot these out really quickly. You want to do these things accurately. 14, 15, 16, 18, 19. Okay. All right. So now the name of the game here seems to be approximating, like pulling out tens from this list. So that's what I'd be looking to do, and just start easy, right? And then you're going to gain momentum. Easiest one, of course, is 2 and 5. So that's 110. You can also grab 3 and 7. That's just above 20. So basically 10 times 2. 11 we can basically just call 10 for now. And we're going to see like how our approximation matches up with the answer choices. But 11 for all intents and purposes, because the answer choices are a power of 10 apart, calling 11 10 is not going to make a difference. 13 we can also call 10. Maybe that's pushing it a little bit, but I think we're going to see. 17 I would call 20, and maybe that kind of balances out the 13 to a certain extent. And then 19 I think we can also call 20. I'd probably just make a new whiteboard. I think that's easier than trying to like create like a different list in the same one, and we can do the same thing, just kind of give it some space. And now I'm just going to pull out my 10. So 2 and 5 is 10. 3 and 7, we're calling that 20, so that's 10 times 2. 11 is basically 10. 13 is basically 10. We're calling this one also 10 times 2, and same thing with 19. We're calling that 10 times 2. Now we're just going to count things up. So we've got 1, 2, 3, 4, 5, 6. We've got 10 to the 6th and times 8. And now we need to figure out, well, which power is that closest to? And I think that's pretty clearly closest to 10 to the 7th, C. Now you might say to yourself, well, but we were under on some, we were over on others. Is it possible that, our estimation made it so that we approximated to the incorrect answer? Yeah, that is possible. That said, it's not like we have 10 to the 6th times 5.2 or 10 to the 6th times 6, right? We're pretty squarely in the direction of 10 to the 7th. The other way to like feel more sure about this approximation is to think about the numbers that you approximated. And if we look at our list, I think we're going to find that we'll have more certainty. The 2 and the 5, we didn't do much. The 3 and the 7 we approximated up, right? Up by 1. Down by 1. The 11 was down by 1. And then the 13 was down by 3. This one. Okay, so let's say that these were all sort of equivalent moves. They're not, but let's say they were. The up by 1, 19 cancels with the down by 1, 3, 7. The up by 3, 17 cancels with the down by 3, 13. And then we're still potentially actually underestimating. So we're like 10 to the 6th times 8 plus, using this like very crude method. However, going up or down by a certain absolute amount, by a number, like 1, 2, 3, whatever, is going to vary, like the effect will vary depending on the number that you're increasing or decreasing. And actually, the smaller the number, the greater effect an absolute move makes. So that, like, if you increase the number 1, right, by 1, you get to 2, right? So you get 100% change. If you increase the number 1, the number 2 by 1, right, you get to 3, which is a 50% change. If you increase the number 100 by 1, right, you're going to 101, which is a 1% change, right? So this is this, that's this, and that's only this. So you can see that if you're starting with the smaller number, you're going to have a greater effect with whatever fixed absolute number you're adding on. And notice that we have more, the smaller numbers, right, 11 and 13, with the same absolute change, 1 and 3, are going to matter more than the bigger numbers, 17, 19, that have the same change, 3 and 1. So not even considering the fact that we've got that extra 3 times 7 that we also estimated down, the 11 and the 13 changes absolutely cancel out the 3 and the 1 changes, and in fact have a greater impact. So there is some math behind this that can kind of help you with certainty figure out that the product of all prime numbers less than 20 is in fact closest to 10 to the 7th, not 10 to the 6th. Just a quick add-on here, because I was noticing as I was looking this over, just to drive this point home, this point here regarding the smaller numbers with like the same increase have a way bigger impact, right? The 100% versus the 1%, 1 versus 100. Just want to highlight that, like, one more step in that process. So let's look at the difference between like 2 and 100, the product, versus 3, right, times 100, and 2 times 100 versus 2 times 101, right? So for this one, we increased 2 by 1. This one, we increased 100 by 1. This would have actually been much better with the keyboard. The mouse is fine. It's just a little sloppy. But hopefully the point is really clear that adding the same number to a small number, 2 to 3, versus a big number, 100 to 101, has a much bigger impact in that this one we've gone from 200 to 300, this one we've gone from 200 to 202, right? So 300 versus 202 is our difference there. And hopefully that makes it really, really clear that, for instance, like the 3-7 estimation that we did, right? The 21 that we brought down to 20, right? That one that we brought it down means more than the 19, right? That we brought up to 20. So this thing more than makes up for this thing. And that's just one way that you can definitively prove that we are, in fact, closest to 10 to the 7th. And that concept, which we call absolute versus relative, absolute being what we're talking about here, if you add a 2, a 5, or a 10 to something, the impact that number will have depends on the size of the number you're adding it to. So the smaller the number, the more impact. The bigger the number, the less impact. That's different than multiplication, relative. If you multiply something by 2, it doesn't matter what you're multiplying. It's always going to be times 2. So 2 times 2 is 4. That's 2. 4 is twice 2. 100 times 2 is 200. 200 is twice 100. And this concept of absolute versus relative comes up on I would say just about every GMAT you'll take. So it's certainly something that you want to be very comfortable with. All right, thanks for watching. Comment with any questions, and because this is like the online whiteboard edition, certainly comment with your experiences with the whiteboard. And good luck on your GMAT, and we'll see you next time.